Hey everyone, welcome back to part 3. This is the final part of the function calling series. This video builds on everything from part 1 and part 2, so make sure you've seen those first. In this video, we'll cover in detail how to define functions using the OpenAPI style schemas, how automatic function calling works, and the best practices to make your function calling and your function definitions production ready. So let's get started. Okay, so this was an example of the function calling flow. Next, as promised, I did say that we will dive deep into how function declaration happens in the OpenAPI schema format. Okay, now the purpose of the function declaration is to tell the model what are the tools available to it and how to call those tools. So we pass a tool that contains one or more function declarations. As we saw, the functions are defined in a JSON format. Okay, and the the keywords that you can use or the keys that you can use in the JSON are a subset of the OpenAPI schema. So it's very important for us to understand what can be used and what cannot be used, and that's what we have provided here. So these are a couple of fields that are are supposed to be given. This is the name. This is the name of the function that you will provide as part of the function declaration, in the description parameters and so on. So this is the, if you remember, when we in the example we defined a function declaration, right? So this is the same thing, name, description, parameters. If you want to understand the complete list of supported keywords that you can use, and you would have to, because if you're building AI applications, Gen AI applications, you need to provide the schema and it has to be extensive, so you should know what keywords are supported. So if we just go here to this link, so if you see here on the right hand side, you will see all the possible supported keywords that you can use in the function declaration, and the definition of each is given and whether it's required or not. For example, so we used enum in the function declaration. Okay, I've also included for ease of use, I've also provided those keywords here and what they mean. Now, a very important note. We just saw how to create a function declaration and what are the possible keywords that you will use when you describe the schema, JSON schema. But interestingly, the Google Gen AI package can automatically construct this function declaration just by providing the Python function, and this makes our life very easy. So if you there's this method where you can say types.function declaration from callable, and if you provide your function, now this time you are providing the actual function. You're not providing a function declaration, but you're providing an actual function. If you provide an actual function, it can automatically create the schema, this function declaration. So you don't have to manually go and write that JSON schema. So naturally, the second question is, when should we use manual versus this automated function declaration? So usually you can use the automated part when it's kind of a demo, or your function is simple, it has simple inputs, okay, or you want to just auto run with minimum code. So we'll talk about this in a moment, what auto run means here. So in a way, from callable could be used for lightweight tools or for demo, but when it comes to production level code, it's best to use a JSON schema. It becomes language agnostic. So you're not defining it in Python, right? You're defining it in JSON, and can be used across teams. And then there are certain keywords that you can use in JSON, which also help in strict validation, like we used enums, right? And there are other keywords which you can check. So this will help you decide when to use manual versus automated function declaration. If you look at an example here, we've tried to create this automated function declaration by giving our previous function set light values. So here this is actually the function. Okay, this is actually the function. We gave it to this method, and look what it was able to automatically create. It was able to create the function declaration automatically. So there's description, there is arguments, what it returns, there are types, and so on. We spoke about automated function declaration. Google Gen AI package goes one step ahead, and it's able to do automatic function calling. So till now, I was saying that the Gen AI model does not execute the tool, the function. We parse the response of the model, and we search for a tool call. If there is a tool call, the application code executes it, right? But if you're using Python SDK, there is a feature called as automatic function calling, meaning you provide the function to the model, and under the hood, the Python library execute the function, get the result from the function, give it to the model, and the model is able to give you a response. So in short, what I'm saying is still the model is not able to call the tool, but the library does it on our behalf. So things become very simple. Now what we have to do, we just have to provide the function to the method, and under the hood, first it's able to do automatic function declaration, right? It's automatically able to infer the schema, and second, it is automatically able to execute that tool, that function, without us having to do anything. Okay, so that's what automatic function calling is. You pass the Python function directly as tool, the SDK turns them into function declaration that we saw, it executes them, it sends it to the model, and the model is able to return the final text to you. So it became so much more easy. And that is why it becomes more and more important that when we write functions, they have to they have to have all the information. It should have type hints, meaning what data type an argument is of, and docstring, meaning what does the function do, and so on. So you can refer to this link on what is the best practice on writing a function such that the SDK is able to correctly infer the schema and execute it. Of course, there are few limitations. So the Python SDK can auto build a tool schema that we saw. It understands scalars like int, floats. It understands lists, and it understands pydantic models. Think of pydantic model as a Python library which is popularly used for schema, for defining schema. It does not do a good job with raw dictionary. Now, the first time I saw it, I was pretty confused, but in a moment I'll explain what this means. And if you want to give some strict rules, you can prefer the JSON schema for the function declaration. Let's understand, if you provide an argument which is of the type dictionary, the SDK is not able to properly create a function declaration, and we'll see why. Okay, I have an example for that. Here, right here, now if you look, this is a function called as set coordinates. Bad is because it doesn't work. That's why it's not a good example. That's why it's bad. So here we have an argument which is of the type dictionary, and the key is of the type string, and the value will be of the type float. Okay, we have given the docstring, and we are returning a static response. Here what we are trying to show is how does the SDK automatically create the function declaration, okay, and why a dictionary does not work. So when we use this function and we try to create an automatic function declaration, you will see this gets printed. Okay, till the description looks good, this is a docstring. The name looks good, this is the name of the function. The properties looks partially good because we see chords here. Chords is coordinates, so this is good. But now you don't see that there is nothing inside which tells the model what is the name of the key that will go into the dictionary. So there's a gap here. It's ambiguous. Even though docstring says that the chords must include keys lat and long, you don't see them here. You don't see them here. You can overcome this issue by using pydantic models. Pydantic gives the software development kit SDK a named object shape with required fields. So first we define a quads class which inherits from the base model from pydantic. We say that it has two attributes, lat and long, and then in the same function, again it's good because it's the good example, we this is the same argument, but right now it is of the type chords, and chords has two attributes, lat and long. So now if we provide this function and we try to do automatic function declaration, you will see that in the function declaration, description, name, properties, till here it looks good. Further, under properties, now it understood that there has to be a key called lat of the type float, and there has to be longitude of the type float. This way, the model knows that when it gives a tool call, it has to provide lat and long as part of the chords argument. What we understood here is if you have a complex tool or a function, you must use pydantic to make it much more clear for the model to understand. So just now we saw automated function declaration, okay? But the concept we were discussing was automatic function calling. where the SDK does all the job, right? So let's look at an example. Here we define a tool called as get current temperature. It's able to get the current temperature for a given location. It accepts a parameter location of the type string. It returns a dictionary. Okay, and again, this is a mock tool, so it always returns a static response. What is the difference in automatic function calling is here when you create the configuration inside tools, you pass the exact function directly. So this is a function, this is the exact function. So you're not passing the function declaration, you're not passing the JSON, you're actually literally passing the function. And then the SDK is automatically able to understand that you have passed a function. So when you call the model, for example, here now the prompt is what's the temperature in Boston? Okay. Now, when you call the model with this prompt, the model realizes that it does not have the current temperature in Boston. So it looks for tools. It finds a tool called as get current temperature, which does just that. It makes a tool call, but now the SDK takes that tool call, it executes the function, it returns the result back to the model, and the model is then able to send the final response back to us. So all we do here is we provide the tool, we send the prompt, and we get the response. It's like we are the users now. It's not from the application perspective. It's like we are the users where we send the prompt and we get a response. So if you see the response is the current temperature in Boston is so and so, and it was able to understand because it called this tool and it got this information that the temperature is 25 degrees Celsius. Okay, so this was automatic function calling. Now, as you use these tools in developing applications, you'll see different types of variations. The most obvious one is no tool path. That means a user sends a prompt to the model and the model is able to respond to it without using any tool. Then there's a clarification question. Now, if the user sends a prompt to the model and the model realizes that it needs to do a tool call in order to fulfill that response, but the information given by the user in the prompt is not sufficient to do the tool call. Okay, for example, the user asks what's the weather and they have not provided the location. But in order to call the tool, the model requires the location. So then the model may ask a follow-up question, a clarifying question saying, which city are you asking about? Okay, so this is second. Third is parallel function calling. This is where the model can call multiple tools parallelly. Here the tools have to be independent of each other. And another variation is called compositional function calling, a fancy word for sequential function calling, where one function, as you would have guessed, one function gets called after the other. It's like chaining multiple function calls. A very easy example for this is if a user prompts saying get the temperature in my location. So the Gemini API first invokes a tool which helps to get the current location of the user. Once it gets the location, then it calls another tool get weather to get the weather at that location. Okay, so this is sequential. When you provide tools to the model, there are certain configurations that you can do to decide how should the model call the tools to control the tool calling process. Okay, so they're called as function calling modes. The default is auto, meaning the model has the choice to decide when to call the tool and when not to. And this is the most flexible one because that's what we are depending on the models for, right? Where they are smart enough to tell us which tool to call and with what arguments. Then the second calling mode is any. Here the model is constrained to always predict a function call and it always guarantees a function call. So there could be applications where you always want the model to call a function or call a tool, and that's why you could use the any calling mode. There is also additional configuration where you can provide the allowed tool names or function names that the model can call. So the model can only choose from this list. And finally, none. Now here the model is prohibited from making any function calls. The model cannot call any tools. And you would say, why would we even provide this, right? And the reason is because you can temporarily disable this without removing your tool definitions. So if you're testing something and you're developing something, and at that point you want to switch off all the tools, but you don't want to change code, right? You don't want to change anything there. You don't want to change the tool definition or remove them. Then you can just set this mode as none so that the model will not call any tool. You can test whatever you're testing. Best practices. So this is the last section of the video. First is the function and parameter descriptions. By now you would have guessed that providing proper descriptions to the for the function and the parameters is extremely important, because that's the information that the model has to take a decision whether to call a tool or not, right? So you have to be extremely clear and specific in the description, because the model relies on this to choose the correct function and provide appropriate arguments. Next is naming. You could follow normal function naming practices. You could use a camel case or you could use underscores. Next is strong typing. You should ensure that the data type for each argument is very clearly specified. For example, the argument units is of the type string. It can only take these two values, Celsius and Fahrenheit, right? So you have to be very specific. Tool. In a complex application, you may use a lot of tools, but it's suggested in the documentation that you use ideally 10 to 20 tools, active tools, remove the ones which are not being used or not required. Then there is prompt engineering. So this is not directly related to tool, but as part of the prompt, you can specify information that's specific to the tool, right? For example, tool usage. In what situation should the model use the specific tool? Then there is temperature. So this is a parameter that you can give to the model to control the creativeness. If you want a deterministic outcome, for example, when you're calling tools, you want the model to be deterministic, as in it should be able to call every single time when required. Then you give temperature is equal to 0, which reduces the hallucinations. Validations. Now, if there are any risky actions or impactful actions that the model is going to take, it's best to provide an instruction in the prompt to ask for a confirmation. For example, if it's related to a refund, we should provide an instruction in the prompt saying that if it's about a refund, always ask for a confirmation from the user. Then error handling. So now we saw that we are providing tools to the model which are functions, and there is a chance that the function may fail, because as part of the function we are calling external systems, and if the external systems are down, how will the model know what to do, right? So that's where, as part of these tools, as part of these functions, we should have probably a try except block, and if something fails, you are able to return a graceful structured response which tells the model that the function execution failed. So this was all about function calling. I hope we were able to cover the most important concepts and you were able to understand what function calling means in depth. You know, what are the different terminologies used? How does the function calling process work under the hood? Most importantly, something that I found difficult to understand initially, or I didn't know of, was the function declarations. What is OpenAPI schema? How can we specify it, and so on. So I hope this was useful. I hope this was clear enough. So yeah, we've come to the end of the video. If you've liked this video, if you've liked the content, please subscribe. I will link this notebook in the description below, so you can download it, you can use it, you can refer to it as notes in the future. Thank you so much.